test tomorrow. You should have in front of you a worksheet packet that kind of has some PowerPoint slides that look like this. You should have a ruler for later on, and maybe you want your calculator. Why don't you get all your stuff organized? So pause the video, get everything, and then we'll get started. Okay, here's the game plan. For each topic, for each lesson from your textbook, there's 2 PowerPoint slides. I'm going to do one with you, and then you're going to pause the video and do the second one that has similar problems. Let's start with 5.1. 5.1 was on rate of change. For your test, you're going to need to know your slope formula. You need to remember that you put your y's on top and your x's on bottom. You don't want to mix that up. So on number 1 here, if I'm finding the slope, y2 is negative 4, and I'm going to subtract y1, which is negative 3, over x2 is negative 8 minus 2. And then you need to simplify. Change. So that's a negative 4 plus 3. That's a negative 1. Be careful with your signs on this slope formula. And that's going to be over negative 10. That would simplify to a positive 1/10. So that's our slope. Let's try number 2. It looks like the same kind of problem. Y minus y over x minus x. What's different here is that your denominator ends up being a 0. Recall that if your denominator is a 0, that's undefined. This would be a slope of undefined. Now I'm going to make some extra little notes every once in a while. If you want to jot those down, that might be good. Remember that if you do your slope formula and you have a 0 over something, that's okay. So that would be 0. That would be horizontal because of Huygens. Okay, if you have something over 0, that is not acceptable. So we say that's no, you can't have 0 on the bottom. That's undefined. And that's going to happen whenever your line is a vertical line. Number 3 is a different type of problem. You're looking for slope. Remember, this is just y equals mx plus b. The slope is the m. So in this equation, the slope would be 4. Not 4x, don't include the x. It's just the number in front of the x. A different type of problem might be a graph where you have to count your rise and your run. So you pick your leftmost point, so that's this one here, and you count your rise. 1, 2, 3, 4, 5, 6, 7, 8. And your run is 1, 2, 3, 4. And if you reduce that, that would reduce to 2 over 1, or just 2. If I give you a table, you should be able to find the rate of change. Remember, you're looking at how is the y changing. So it looks like it's going down 20 every time. Every time it goes down 20. That's your change in y, negative 20. And then you come over here and see what is your change in x. That looks like that's going up 10 every time. So that would be a positive 10. That means your slope would reduce to a negative 2. Recall that this rate of change here has to stay the same, and this has to stay the same for this to be a linear situation. I would probably give you something that's linear if I'm going to ask you to find the slope. Okay, the last thing that we did with slope was to interpret the slope. What does it mean to have a negative 2 slope? Well, and the denominator is the change in x, so that's minutes. So what's going on with this? Well, over time, this is the water left in the pool, and since your rate of change is negative, that must mean that we are losing water, and we are losing water at 2 gallons a minute. And that's what you would write, losing water, and it's your rate of change, 2 gallons a minute. Notice I did not put -2 because I used the word losing, and that implies the negative. There's other ways to write that, but that's how I would write it. Okay, so now what you're going to do is you're going to pause the video, and you're going to go do the 5.1 slope. That's your turn. And use this for your notes as you do it. Okay, let's talk direct variation. You need to know the formula y equals kx. That's what we use for direct variation. And that's what we write when they say y varies directly as x. This is the formula for that. Y varies directly with x. And then I'm going to give you some sort of information to help you find that k value. Show some nice work on this. It's going to be a y equals kx. That's how we start. And then we take the two pieces of information and we plug those in. So y is 20 when x is 8. We're going to look for the k value, so we divide by 8. And k would equal, and we can go ahead and probably go as a decimal, or you can leave it as a fraction. Either one is okay. As a fraction, that would reduce to 5/2. If you went to a decimal, it would be 2.5. Either one is okay with me. Now, that's the first answer. You have to figure out what k is. That's what they ask you right here. Find the constant of variation. We did it. Now, write the variation model. To write the variation model, that means rewrite the y equals kx, but get rid of the k and put in your 5/2. That's your second answer. The third answer, and we typically have 3 different things that we would box in. The third one is use the model to find y when x is 3. Okay, so if I'm going to find y, here we go. Y equals 5/2 x, but they told me x was 3. I'm going to plug that in for x. I'm going to write it as over 1 since the, oops, sorry, got ahead of myself there. This is not a 3. Y is going to end up equaling, multiply straight across, 15/2, or if you went as a decimal, you could write 7.5. And that's your third answer. You need all 3 steps on those problems. Does this table represent direct variation? Well, for it to be direct variation, it has to have this constant. We call it a constant proportionality, but this is really, if you'll look at this y equals kx, is basically slope-intercept form. But instead of a b, well, the b must have equaled 0. Direct variation models will always be linear. This is a linear model with a y-intercept of 0 every single time. When they asked me, does it represent direct variation, I would want to make sure that there was a constant rate of change. That would be the k. And then I'd want to make sure that it went through the origin, 0, 0. Let's check that on this one. The change in y appears to be, it goes, oh, that's tricky, +5, +5, +5, and then it went +10. Be careful there. plus 1, plus 1, plus 1, and then it jumped a plus 2. Your change in y was 5 over your change in x was 1, until you got to the very last one when the change in y was 10 and the change in x was 2. But aren't these actually equal to one another? They both equal 5. So because it jumped at the end, as long as it jumped on both the x and the y, that's okay. This has a constant rate of change of 5. That's my k value. The next thing I would have to check is whether it crossed at 0. Remember that sometimes you have to back your table up so that it gets back to a 0. So since it was a plus 1, plus 1, plus 1, I just subtract 1 to get it back to 0. And same thing here, if I have to back up my table, since it was a plus 5, plus 5, plus 5, I would subtract 5 and I'd end up back at 0. Well, that's a good thing. I want 0, 0 to be a point because that'll give me a y-intercept of 0. So to answer the question, does it represent direct variation? Yes, it had a constant rate of change and it crosses through 0, 0. And if I had to write the equation, it would just be y equals 5x. My k value is my slope. Okay, pause the video and you do the next slide by yourself. Alright, we're looking at 5.3, Slope-Intercept Form. You need to know Slope-Intercept Form. Y equals mx plus b. Write that down on your slide. That's Slope-Intercept Form. And we're just going to do a bunch here where we have to write the equation. Sometimes they're going to hand you exactly what you need, the slope and the y-intercept. If they do, you just plug -3 in for m and 10 in for y, and you've got it. There's Slope-Intercept Form. Usually we have to work a little harder for it though. Look at number 2. We know the slope, that's helpful, but instead of them giving us the y-intercept, they gave us a point. That's your x and your y. Now this is Slope-Intercept Form, so I'm going to use this method here and plug in everything and go solve for b. The y value from the point was -1. The m value is my slope. The x value from my point was 3. And I don't know b. That's what I'm going to look for. I can add the 15 to the other side. So it looks like 14 is equal to b. Well, once you know your slope and you know your b, your y-intercept, you can write your equation. Y equals -5x plus 14. That's the equation of the line. Alright, let's try one that's a little bit harder than that. What if they didn't even give me the slope? They just gave me 2 points. Well, that means I get to go find the slope. So start off with your slope formula. And you do y2 minus y1 over x2 minus x1. That becomes a 1 over -3. Alright, so we've got the slope is -1/3. We've got that. And then you get to pick one of these points for your x and y. It doesn't matter which one. Pick whatever you want. It's going to work out the same. I'm going to pick the 6, 4. Alright, so then I go over here to y equals mx plus b. And I fill in the y value. That's a 4. The m is -1/3. The x is 6. I'm going to go ahead and put that over 1 since I'm dealing with fractions there. And I'm going to find b. I can reduce my fraction, which is helpful because that actually multiplies nicely straight across as a -2. Add 2, equals negative 1/3 x plus 6. Now you pause this video and do the slide on 5.3 on your own. The second form of an equation that we learned was point-slope form. Point-slope form is y minus y equals m times x minus x. Okay, that's really what I wanted right there. Write the equation in point-slope form. Okay, so there's that equation that we're going to be using this time. The slope is negative 1/2. It goes through 8, negative 3. Well, look at what they gave you. They gave you a point and the slope. That's what you need to write this equation. All you do is plug it in. You leave the first y there minus the y value, which is negative 3. Okay, so that's actually going to be y plus 3 then. That's going to go change. So y plus 3 equals m is your slope, negative 1/2. And then x minus your x value, which is 8. And you get to be done. That's it. That's point-slope form. Okay, what if it goes through 2 points? Well, then I need to find the slope, so let's do that. M is going to be y minus y. 1 minus negative 2 over x minus x, negative 1 minus 2. Okay, if I do change, that becomes 3 over negative 3. Well, that comes out nice to just a negative 1. So now we know the slope is negative 1. And then you're going to pick one of your 2 points. I'm going to go with the 1s here. And let's go put this into point-slope form. So using this formula up here, I leave the first y there, and then I subtract my y value, which is a 1, equals m is my slope, negative 1, and then x minus the x value from my point, which is negative 1. And then I would probably do change on that, so let's call that a plus sign instead of minus. There we go. There's our equation in point-slope form. On this last example, they asked me to write the equation in point-slope form and then distribute and convert it to slope-intercept. Well, they're being nice. They're giving me the point and the slope, so I'm going to just jump right into my formula. It's going to be y minus the y equals m times x minus x. So x minus negative 10 turns into plus 10. Now that's point-slope form. If I want to convert it, then I have to distribute to get rid of the parentheses. And that looks scary, but it's not, because if you put your 10 over 1, the 5 and the 10 can reduce, and it just becomes plus 4. The next thing that I would probably do is try to get the y by itself, because slope-intercept form is y equals mx plus b. Let's just add that 3 over to get the y by itself. Y equals 2/5 x plus 7. Now it's in slope-intercept form. Alright, pause the video and you go do your slide. The last form that we learned was standard form. and putting them in standard form. On this first one, we have the x with the number. What I want is that I want that y value over here with the x, and I want the number over on that side. I'm going to move the 9 over here. But I'm also going to move the 3y over with the x. Now these are not like terms. You can't do anything with the 8x and the 3y. It's just going to be 8x minus 3y equals, and we have a negative 9 still sitting there. That is standard form. Let's try one that has a fraction in it. It's a 2/3. Well, typically what we do is we immediately get rid of the fraction by taking everything times whatever your denominator is. In this case, the denominator is a 3. I'm going to take everything times times 3. This will be times 3, this will be times 3, and this will be times 3. Now, I don't love the way that's typed in there, because if you take a 3 times a 2/3, look at it more vertically rather than that slash in there, what's going to happen with those 3's? They cancel. That's what we wanted to have happen, because then it's just 2 over 1, or 2. So when I multiply everything, I'm going to have 3y. 3 times 2/3 just becomes 2x, and then it's a minus 21. Last step is to get the x over there with the y. Standard form would be negative 2x plus 3y. Notice that you want to put your x before your y. Equals negative 21. And there's our standard form. One of the reasons we use standard form is because it's really easy to find the x and the y intercepts. Remember, to find the x-intercept, you put 0 in for y. To find the y-intercept, you put 0 in for the x. Let's try it on these two. On this first one, if I put, so I'm going to look for my x-intercept. If I put 0 in for y, then this whole term disappears. Even the minus sign is gone. That's just 0. And look at that. What do you think x would have to be? Well, divide both sides by 3. X would be negative 8. Let's try again. Let's do the y-intercept. That means I got to plug 0 in for x. So this whole term is going to be gone. Now that negative is attached to the 8, so it's still there. If I divide both sides by negative 8, the y-intercept would be 3. And there I have it. The two intercepts. Okay, we're going to try it one more time. And this time we're going to graph it when we're done. The x-intercept over here. You plug 0 in for y. What do you think x needs to be? Negative 4. To find the y-intercept, you plug 0 in for x. You're always plugging it in for the opposite letter. If I plug 0 in for x, then what's y going to equal? Negative 1. Once you find the intercepts, you can go over here to a graph and plot them. On the x-axis, I'm going to plot negative 4. And on the y-axis, I'm going to plot negative 1. And then you can use your ruler to draw a nice straight line. So that's one way that we've learned how to graph lines, is by using the intercepts. If you have an equation in standard form, that's a nice way to graph it. Remember, though, that we always wanted these two numbers to be multiples of this one. That's how we knew intercepts was going to work nicely. Okay, pause the video and you go do your slide. let's talk parallel and perpendicular lines. Remember that parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So on this first part it says determine if the equations are parallel, perpendicular, or neither. In order to compare them, they need to be in slope-intercept form so that you can identify the slope. This first equation is in slope-intercept form, y equals mx plus b. And I can see the slope is 2/3. But the second equation is not, so I'm going to rearrange that. I'm going to add the 2x. Put the x before the number so it looks like mx plus b. Divide by 3. Y equals 2/3 x plus 2. And now the slope of this one is 2/3. So when you look at those, you should say that those, oh look, that's the same. So what do you think? Parallel, perpendicular, or neither? Well, if it's the same slope, then they are parallel. Okay, let's try one more time. Again, the first one is in slope-intercept form, so I know the slope is 1/4. The second one, I'm going to have to put in slope-intercept form. Move the x to the other side. Divide everything by 4. Y equals, and think of this as like a negative 1x. That means the slope is negative 1/4. Plus 10/4. I could reduce that to 5/2. That's not very pretty, but I don't really care because all I'm looking at is the slope. Okay, so you have a 1/4 and you have a negative 1/4. Are those parallel, perpendicular, or neither? Hopefully you're thinking neither. They're not quite the same slope because one's positive, one's negative, but they're not, and they are opposite, but they are not reciprocals, and they have to be both for it to be perpendicular. I don't think that works. That would be a neither situation. Okay, the other thing that we did with parallel and perpendicular lines is we'd write the equation of the line that would go through a particular point, and then it's going to be perpendicular or maybe parallel to a particular line. Okay, the only reason that they're telling me this right here is to figure out my slope. I don't use this for anything. All I look at is, oh looky there, the slope is 8. Now if I want to write the equation of a line that's perpendicular to that, then my slope needs to be the opposite reciprocal. If they said parallel, then I'd want to make sure it was the same slope, and I'd use a slope of 8. But this is perpendicular, so the slope I'm going to use is the opposite reciprocal. I'm going to use a slope of negative 1/8. And then I'm going to use that point 6, negative 2. And I'm going to go write the equation of the line. And when you write that equation, you're eventually going to want that in slope-intercept form. But all chapter I've given you the choice. You can either do point-slope form or you can use slope-intercept form, whichever one you want. Let's go do it. So I'm going to have a y. I'm going to do slope-intercept form. Y equals mx plus b. The y value is negative 2. The m is negative 1/8. The x is 6. And the b, don't go over here. Don't grab that b. That has nothing to do with it. I'm looking for b. So negative 2 equals, that's a 6/1. The 6 and the 8 could reduce. Looks like it is a negative 3/4 plus b. I'm going to add 3/4, add 3/4. So this is our first one where we really had to work a little bit on our fractions. I'm going to do a little side note here. I've got a negative 2 over 1. And I'm trying to add 3/4. I need a common denominator. Looks like I need to take this times 4 and 4 so that it'll end up being a negative 8/4 plus 3/4. Now we have a common denominator. What is negative 8/4 plus 3/4? Negative 5/4. Alright, then B is going to be negative 5/4. Alright, I've got my slope. I've got my y-intercept. My equation would be y equals negative 1/8 x minus 5/4. Alright, pause the video. You go do parallel and perpendicular lines. Alright, lesson 5.7 was on scatter plots and trend lines. So I've given us a scatter plot here based on how many people go to the beach, dependent on what the temperature is. Alright, so if I give you this scatter plot, you need to be able to kind of draw in a good best fit line. This is going to be a little bit tricky for me. I'm doing this on an iPad and we'll see how this comes out. You got to use your straight edge, so you're going to grab your ruler and you're going to draw in your best fit line. Okay, that wasn't perfect, but that'll work for me. Okay. Oh, I'm sorry, I got a little ahead of myself. Let's answer the questions. It says determine what relationship exists. The relationship is that correlation. Does this look like a positive correlation, a negative correlation, or no correlation? And since it is increasing, it has, just like slope, then we would say that it has a positive correlation. As far as estimating an R value, remember that a perfect scatter plot where all the points lined up would give you an R value of 1. This does not line up perfectly. It's not awful, but it's not great. I might give it like a 0.7 or something like that. That doesn't have to be perfect. There's no magic value there. Just understand that if it was a perfect scatter plot, it'd be a 1. And if there was no correlation at all, where it was just dots everywhere, it's a 0. And you have to pick something in between there. Okay, find the equation of that trend line. Now, what you're going to do is you're going to draw that trend line in there. And then you have to pick 2 clean grid points. These are not necessarily points that from the scatter plot, but they're points that cross the grid lines nicely. Okay, if I'm going to look at this, I would say, and then we're going to box those 2 points in. I'm going to say this point right here looks like a pretty good grid line point. What is that ordered pair? Let's see, it's 92, 525. And then I have to find another point that crosses nicely. Now my line is not very straight, so I don't have great points, but I mean it doesn't look like it's crossing great, but I do kind of like this point right here, and that's actually going to be a pretty easy point for me to use. Let's write that ordered pair. It's always smart to use 2 points that are kind of far away from one another. If you get them too close, sometimes your slope is off a little bit. The farther away, the better. That ordered pair is over 80 up 0. Alright, so I've got my 2 points. And I'm supposed to write the equation of the trend line. So we're going to do what we've done on these previous slides. That's why we were doing that, is writing the equation of a line given 2 points. Well, I have to find the slope. So y yours positive. If you subtract it the other way, both of yours are going to end up negative, which will end up positive. 92 minus 80 is 12. Now, we always went to our calculator on these. We want to go ahead and get a decimal value for that. I got 525 divided by 12. I'm going to my calculator. I got 43.75. Now, we won't all get 43.75, but we should all get something pretty close to 43.75. Once you know your slope, then you grab one of your points. I'm going to grab this one, and let's go write the equation. Last time I wrote the equation, I did slope-intercept. This time I'm going to do point-slope for those of you that prefer that method. And I'm probably going to run out of room, so I'm going to go ahead and write this down here in the next space. I'm going to have a y minus my y value was 0 equals my m value, 43.75, times x minus 80. I have to distribute. Minus 3,500. All right, there's our equation. Now, the last question says, use your equation to predict the expected number of visitors if it's 105 degrees. All right, so let's look at this. If it's 105, I imagine lots of people are going to want to go to the beach to cool off. What we would do is we'd have to decide this 105, that's a temperature. That's our x value. Our temperature is 105. So we're going to grab that 105 and put it in for x. I'm going to come over here on this side now. Y equals 43.75, and then I'm going to put in the 105 minus 3,500. And then I just type in 43.75 times 105, and then I subtract 3,500. And I end up with a y value of 1,093.75 visitors. Of course, we can't have part of a visitor. We can't have 0.75 of a visitor, but for the math part of it, we'll go ahead and leave it exact, and we'll know that we would round that off. Okay, pause the video and you try the next one on your own. Okay, the last lesson out of this chapter was 5.8, and it was on absolute value graphs. Absolute value are always going to graph as a V shape. And when you take the absolute value of x plus, and then we would put something in here, and then we would add something out here. All right, this number here, move your graph left or right. And you would always do the opposite sign. So since that's a plus, I'd actually move left, which seems backwards. If it's a minus sign, then I move right. Okay, this number here is going to move me up and down. And I do what the sign says. If it's a plus sign, I'm going to go up. If it's a minus, I'm going to go down. And then the other thing we had to remember was sometimes there was a negative sign out in front, and that would reflect it upside down. All right, so let's try some of these. On this first one, this plus 2 right here is going to move me left or right, and because it's a plus sign, it's actually going to go left 2. And then this minus 1 is going to take it down 1. Now what we're moving the whole graph, but what we're plotting is that vertex. So normally the vertex would be at the origin, but I'm going to go left 2, down 1, and now here is my vertex. And then the slope was always just rise 1, run 1. So plot some points to keep that accurate, and then go the other way also, some matching points, and then draw your V shape in there. And this is way faster than doing those tables that we were doing in the last chapter. Okay, let's look at this next example. This one has a negative, so that tells me my V shape is going to be upside down. And this minus 5 is a horizontal movement, so it's moving left and right. Since it's a minus sign, it'll actually go right 5. There is no number out at the end, so it must not go up and down at all. I'm just going to move right 5. Here's my new vertex. But my V shape is upside down, so plot those points, keeping that nice slope of 1. And then graph your V. Okay. On the last one, I've given you the graph. We have to figure out the equation. So we have to look at this vertex. That's our left and right movement. But notice that it also is upside down. Your equation, we should be able to just write it. It's going to equal a negative because it's upside down. And then inside the absolute value, I'm going to have an x. And we have to decide, well, it went left, right, from the correct. Okay, left 2 spots. To go left 2, I need to write that as a positive 2. Because I do the opposite sign. Anytime you are inside of these absolute values, you do the opposite sign. But now, for the last part out here, this is my up and down motion, and it looks like I went up 3. And I do what it says. Since it's an up, I put a plus sign, 3. And that's our equation. Okay, now you pause the video and you wrap up your review sheet.